Okay, so in the previous video we had a look at deriving these two formulae here. Well, these three formulae really, one for slope, one for the y-intercept. This is the equation of our best line of best fit. So what I'm going to do in this video is just have a look at using these formulae to find the equation of the line of best fit for these points here. I've just randomly picked 5 points, and we're going to find the slope first. Okay, so we're going to use this formula here to find the slope. So let's start. Now we've got to find each of these individual terms here. There are 4 terms here, so we're going to find each individual one. So we're going to start with x, y. So we're going to do x, y. We're going to find the mean of the x, y. So in other words, we're going to multiply each x by each y and get the mean of those. So let's start with this one here. We got minus 1 times minus 2, which is plus 2. We've got minus 3 times minus 2, which is plus 6. We've got 2 times 1, which is 2. We have 1 times 2, which is 2. And we have 3 times 4, which is 12. Now we have 5 points here, so we're going to divide by 5. And when we do that, we get 6 and 2, 8, 9, 10, 11, 12, 24 over 5. Okay, so that's the first one. Now let's do these two here. So we've got to find an x bar and a y bar here. So let's do the mean of the x's first. So let's see, we've got a minus 1, we've got minus 3, we've got plus 2, plus 1, and plus 3. Okay, and we've got to divide by 5. So if we add all these up, we have minus 1 minus 3 is minus 4, plus 2 is minus 2, plus 1 is minus 1, plus 3 is 2, 2 over 5. Okay, so let's do another one then. We got to do the y bars here, so let's do that. We'll do it over here. Y bar here, so that's going to be the average or the mean of our y's. So we got a minus 2, we've got a minus 2, that's these two. We've got a plus 1, we've got a plus 2, we've got a plus 4. Okay, so let's add these and divide by 5. So in this case we have minus 2 is minus 4, plus 1 is minus 3, plus 2 is minus 1, plus 4 is plus 3, so we get 3 over 5 for our y bar. And the last one I'm going to do here is the x squared bar here. So it's the x squared, and then we got to get the mean of the x squareds. So we got to square each of our x's. So here we have, let's see, we have minus 1 squared, which is 1. We have minus 3 squared, which is plus 9. We have a 2 squared, which is 4. We have a 1 squared, which is 1. And then we have a 3, which we have to square, which will give us 9. Divide that by 5. That will give us 1 plus 9 is 10. Plus 4 is 14, plus 1, 15, plus 9, 24. So we have 24 over 5 here. So these are all the values we need to put into our formula here. Let me just move that down a little bit here so that we can use it again. So these are our 4 values here, and we're going to put those into this formula here. So okay, we'll do this in white. Okay, so let's stick all those values in. Well, we have x, y bar here, x, y, the mean of our x, y, so that's 24 over 5. That's 24 over 5 minus x bar, y bar, so that's going to be these two here, 2/5 multiplied by 3/5. And then we've got to divide by, let's see, x squared, mean of our x squared, so that's going to be 24 over 5. And then we've got x bar squared, so we've got to get the mean of our x's, which is 2 over 5, and we've got to square that. Okay, so let's do all of this. Let's just simplify it. 24 over 5, we have 2, 3, 6 over 25. Here we have 24 over 5, and here we have 4 over 25. Okay, so the next thing I'm going to do is just simplify our numerator and denominator here. So again we have our m here. So on the top here we're just going to add these two fractions on top. So our common denominator is 25. 5 into 25 is 5. 5 24s is 120. and we have minus 6 here. On the bottom, same thing again, we'll just add these two fractions. Common denominator is 25, so again we'll end up with 120 up here. This time we're subtracting 4. Okay, so here we end up on top with 114 over 25. On the bottom we have 116 over 25. And if you flip this one upside down and multiply, you'll find the 25s will cancel and you'll just end up with 114 over 116. So that's roughly, it's almost 1 actually, so let's see, 114 divided by 116, it's 57 over 58, 57 over 58, which is 0.9827 and so on, so it's very close to 1. Okay, so now what we can do next is, if we come back up here, we have a formula here for C, and what we can do is do the same thing again, put all these values in here, and we'll end up with our y-intercept, where our straight line cuts the y-axis. But an easier way of finding C is just to use this formula here. This is just our formula for a straight line, y is equal to mx plus c, where m is our slope, x bar here is just the mean of our x's, and this is the mean of our y's, and this is our y-intercept here. So I'm going to use this one, but you can check it out yourself. You can put the values in here as well, and you'll get the exact same answer, but this one is slightly easier to use. So let's do that. So we have y bar is equal to mx bar plus c. Let me just rearrange that to give me c is equal to y bar minus mx bar. So let's just stick in our values here. Well, our mean of our y's, the mean of the y's here is 3/5. So we put that in here, so we got 3/5 here. Our slope, remember, is 57 over 58. And the mean of our x's then, mean of our x's was 2/5. So let's put 2/5 in here. That'll give us 3/5 minus 57 over 58 times 2/5. So we'll get 114 here over 5 times 58, that's 290. Okay, so let's just do this. I'll do this quickly on my calculator here. So we've got 3/5, and then we want to subtract 114 over 290. So that'll give us 6 over 29. 6 over 29. So that's roughly 0.207. 0.207. Okay, so finally then our equation of our line of best fit here, the equation of the line of best fit will be y bar is equal to mx bar plus c. So our y is going to be equal to our slope, which is 57 over 58, so it's almost 1, x plus 6 over 29. So this is the equation of our best line of best fit, if you like. Okay, so that will look something like, let's see, 6 over 29. 6 over 29 is around 0.2. So let me just see, that's going to be, these are our points here. So let me just draw roughly. It's going to be fairly rough, but 0.2 is going to be, well, there's 1, there's 0.5, so 0.2 is going to be somewhere around here. So it's going to go through that point on the y-axis. Now it's going to have a slope of very close to 1, so it's going to be going through roughly these kind of points here, somewhere around here. So it's going to look something like this. Okay, so that's roughly our line of best fit. Okay, so that's it for this video.